All right, we're going to start chapter 11, linear systems. Linear should be the term you're familiar with. We have the base word line in there, and we spent a lot of time practicing graphing lines and finding solutions. Systems is going to be the new term, and we're going to learn what that is today in the introduction. And then these 4 sections are methods to solving solutions. These 2 sections are kind of the unique situations that can happen in systems, and then we're going to apply everything that we've learned up here to inequalities then. Alright, so an introduction to systems. Like we said, system is probably the new word, and that's a set of sentences, and in our case we're going to be talking about math sentences, which together describe a single situation, with each sentence describing a specific condition of the situation. Basically, we're going to be looking at multiple linear equations at the same time. However, we can't solve them alone because we know there's 2 variables in linear equations, an x and a y. But when we have 2 or more equations, we can solve 2 or more variables. So that's kind of the point of doing systems, is allowing us to solve equations with 2 variables. So a little bit of review. A linear equation is something like this. If you remember, we had multiple forms. This is slope-intercept form, because we have our intercept and our slope. Here's our y and our x. X is to the power of 1, which makes it linear. A solution to a linear equation, if you remember, is a point xy that satisfies the equation, meaning it makes it true. So for instance, 1, 1. If we plug in 1, 3 times 1 minus 2. 3 minus 2 is 1. And we're saying y is 1. Yes. Likewise, 2 and 4. Graphically, if we were to graph this line, these 2 points would also land exactly on this line. There's more than these 2 solutions, of course. So, I'm going to predict, what do you think a solution for a system of equations would look like? A solution to one linear equation is a point satisfying the equation. We're looking for a solution for multiple equations. Hopefully you're starting to think that it would be a point xy that satisfies all of the equations in the system. There's lots of ways to find this point, the solution to a system of equations. We're going to learn one method today, and that's by graphing. Graphing works if your numbers are nice, they're integers, and if the equations aren't really crazy. It's a good way to visually see what the solution looks like. But we're going to learn other methods after this for when our situations or equations are not as nice. Okay, so consider the situation. Find 2 numbers whose sum is 22 and whose difference is 8. And we're actually going to change this to 2. Okay, we're going to change that to 2 just so it fits on our graph better. Okay. So I have 2 different conditions. Sum is 2 and difference is 8. Okay, those are my conditions. So I'm going to write 2 sentences that model that. Now, I know you can already think of the numbers that would satisfy this, but throughout this chapter, we're going to be writing a lot of equations from the information, and some things you probably won't be able to just solve in your head, so please get accustomed to writing the equations. Okay, so I always try to figure out what 2 variables am I going to use that represent the 2 things I'm trying to find. I'm trying to find 2 numbers, so I'm just going to use x and y for those 2 numbers. And I know one situation, or one condition is saying their sum is 2. Easy enough. Okay, what would the other condition be? Their difference is y. Sorry, their difference is 8. Okay, and we're going to graph them. Okay, so if you remember from when we did the graphing chapter, we have to solve for y. That's the easiest way to graph. So I'm just doing a little bit of algebra. I'm going to divide by -1. Okay, so here's my two equations. So remember, this is your y-intercept. Y equals 2. So 1, 2. Okay, and then my slope is -1/1. So this is my rise and my run. So down 1, right 1, down 1, right 1, and so on and so forth. If I need more, I can put some more on there. And then here, -8, 1, 2. And my slope is up 1 over 1. Okay? And we're trying to find what two numbers it would be. Well, if we look at a solution, it's a point that would satisfy all the equations. Which point satisfies both equations? This one, right? Okay, what is that point? 5, -3. Okay, let's check. Does that make sense in our situation? Their sum is 2. Yes. Their difference, 5 minus -3 is 8. Yes. There is one way to find the solution to a system of equations. Okay, let's try this one. The equations are already written for us. They're even in slope-intercept form. Okay, so we're just going to practice graphing and finding the solution. So my intercept is 1. My slope is 2 over 1. Remember, everything has to have a rise and a run. So up 2 over 1, up 2 over 1, up 2 over 1. Remember, you can reverse everything. Down to left 1, down to left 1. Okay, I'm going to see if I need any more. So I'm going to do -3. 1, 2, 3. Up 2 over 1, up 2 over 1, up 2. If I remember, my slopes are the same. What does that mean about lines if their slopes are the same? Equal slopes mean parallel lines. So, will there ever be one point that satisfies both of these at the same time? Will there ever be this intersection, this point that is shared between the two if they're parallel? No. So this system has no solution, because there's never one point that both equations or both lines will be satisfied with. Your homework, you don't have to write the equations. Just graph both lines. Find the point where they intersect, because that will be your solution. If there is none because they're parallel, is no solution. Okay?